This is Mrs. Appia with Grade 8, Module 3, Lesson 9, Basic Properties of Similarity. Our essential questions are: Number 1, is similarity symmetric? Number 2, is similarity transitive? The purpose of this lesson is to practice what we learned from Lesson 8 about similarity. We know that similarity means you have a sequence of transformations, dilations, and rigid motions that will map figure 1 onto the other. We know that similar triangles look the same shape because the corresponding sides are in proportion with the same scale factor. And we know that the angles that are corresponding have the same measure. In our exploratory challenge, our goal is to show that if triangle ABC is similar to triangle A', B', C', then A', B', C' is similar to triangle ABC. Symbolically, we say triangle ABC similar to triangle A', B', C'. Then triangle A', B', C' is similar to triangle ABC. Part A. First, determine whether or not triangle ABC is in fact similar to triangle A', B', C'. Use a protractor to verify that the corresponding angles are congruent and that the ratios of the corresponding sides are equal to the same scale factor. Remember to extend the lengths of your triangle before you measure them with a protractor. Pause the video and complete Part A. I measured the angles first, and this is what I found. The measure of angle A was equal to the measure of angle A', which equaled 49 degrees. The measure of angle B was equal to the measure of angle B', which equaled 99 degrees. The measure of angle C was equal to the measure of angle C', and that was equal to 32 degrees. So my corresponding angles are congruent. Then check your scale factor for the corresponding sides. Pause the video and complete this process. The scale factor is the length of the dilated segment divided by the length of the original segment. So we have A', B' over AB, which is 2 over 4, which equals 1/2. The second side, B', C' over BC, is 3 over 6, which is 1/2. The third side, A', C' is 4, AC is 8, and so the scale factor is 1/2. The ratios of the scale factors are the same, and therefore our triangles are in fact similar. Part B. Describe the sequence of dilation followed by a congruence that proves that triangle ABC is similar to A', B', C'. We'll need to dilate our triangle with a scale factor of 1/2, and then we'll use a congruence to map it over A', B', C'. So we need to write the coordinates of each of the points on the triangle. Once you have your coordinates written, use the scale factor of 1/2 and find the coordinates of the dilated figure. Pause the video, do this step, and then draw the dilated triangle. Resume the video when you're ready. Next, you'll translate your closest point to its corresponding point on triangle A', B', C'. So you'll want to translate A'' to A'. We'll move that along the coordinate plane. We'll have to go right 1, 2, 3, 4, 5, and then up 2. And we'll do that with each of the points. Pause the video and complete this step. Finally, we'll need to rotate our triangle into position. We'll need to rotate it 90, 180 degrees around point A. Let's summarize on the next page the steps of the sequence. It says describe the sequence. The steps that we did. First, we dilated. When you dilate, you need to say where you're dilating from. Dilate from center O. Scale factor, 1/2. The second thing that we did was to translate. We translated the dilated figure. And we went right 5 and up 2. Finally, we rotated. When you rotate, say what point you're rotating around, which direction you're going, and how far. So we rotated around point A, and we went 180 degrees. And since we were going 180 degrees, it doesn't matter if we go clockwise or counterclockwise, so we don't need to include the direction for that section. So step 1 was to dilate from center O using scale factor 1/2. Step 2, translate the dilated figure, right 5 up 2. Step 3, rotate around point A 180 degrees. Part C. Describe the sequence of dilation followed by a congruence that proves that triangle A', B', C' is similar to triangle ABC. So what we're doing in this problem is we are taking this triangle that's right over here, and we need to dilate it to make it the right size, and then we will need to move it into position over this triangle. At this point, you hopefully can do that on your own. Pause the video, complete those steps, and resume when you are ready to check it. As you're getting ready to dilate this figure, remember that you are going from the small figure to the large figure, so you will need to use the reciprocal of the scale factor you used before. The scale factor before was found to be 1/2. The reciprocal of 1/2 is 2, so we'll be using a scale factor of 2 to dilate our shape. Pause the video and continue your work. I've dilated the figure, now I'm ready to translate it. Choose your closest point. We're going to need to move it to the left and down. So I'm going to move or translate A'' to A. So I'm going to count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 to the left, 1, 2, 3, 4 down. Pause the video and translate your triangle. I've counted each point and then I'm moving them over 10 and down 4. So I've translated my triangle. Now I have one corresponding point attached to the other corresponding point on the triangle that I'm mapping to. My final step will be to dilate 180 degrees around point A. Go ahead and write that down as well. When you are figuring your rotation, remember it's important that your triangles are labeled so that you are rotating the proper segments. Here I have segment AC quadruple prime and I want to rotate that around so that it is on AC, and that will require a 180-degree rotation. Next, on part C, it says describe the sequence, so let's go ahead and write that out. Our first step was to dilate from center O. Scale factor is the reciprocal of 1/2, which is 2. Our second step was to translate. The dilation gets your triangle the right size. Translating it moves it into position. We translated 10 left, 4 down. At that point, we had point A, the corresponding points on the triangle, and our last step was to rotate. When you rotate, remember to say what point you are rotating around. We rotated around point A, 180 degrees. When you rotate 180 degrees, you do not need to see which direction because it doesn't matter. Question D. Is it true that triangle ABC is similar to triangle A', B', C' and triangle A', B', C' is similar to triangle ABC? And why do you think this is so? Well, we mapped triangle ABC onto A', B', C', and we also mapped A', B', C' onto ABC. So I believe that yes, this is true. They have the same shape because the scale factor gives the corresponding segments proportional length, and the corresponding angles have the same measure. Exploratory Challenge 2. The goal in this problem is to show that if triangle ABC is similar to triangle A', B', C', and triangle A', B', C' is similar to triangle A', B', C', then triangle ABC is similar to A', B', C'. Symbolically, triangle ABC similar to triangle A', B', C', and A', B', C' is similar to A', B', C', then ABC is similar to A', B', C'. So I'm going to take a minute and darken my figures before we continue. Part A. Describe the similarity that proves triangle ABC is similar to triangle A', B', C'. So we are going to be starting out with the smallest green triangle, and we are going to write a dilation and followed by a congruence that will map the original onto the prime. Remember, to do that, we'll need to figure out what the scale factor is. We need to dilate our triangle, and then we'll need to move it into position. Pause the video and complete part A. Dilate triangle ABC from center O with a scale factor of 3. Then translate A', B', C' up 5. So that's moving point A, 1, 2, 3, 4, 5. And when you do that, you move your entire triangle 5 spaces up, and it is in position, and you have mapped your triangle, proving similarity. Part B. Describe the similarity that proves triangle A', B', C' is similar to triangle A', B', C'. Okay, so let's take a look at what we're doing here. In this problem, we've got our primes, so that is our red triangle right here. and we are going to translate, or rather we are going to dilate and use a sequence of rigid motions to map that triangle onto our blue triangle. So we're going to be going to this triangle next. Keep in mind you need to figure out what your scale factor is, dilate it to the right size, draw that dilation, and then move it into position using a sequence of rigid motions. Pause the video and complete part B. The new coordinates that I got are -2, 7 1/3, -6, 3 1/3, -6, 5 1/3. I've dilated the triangle down to the right size. It's triangle A4, B4, C4. Then I need to translate it and move point A4 over to A. In order to do that, I needed to translate 5 right and 3 1/3 down. So I have my triangle down here, and my last step is to move it into position. And I know that I'm going to do a rotation. Then I think, well, how far do I need to rotate it? What you can do is look at the corresponding segments. I know that I need to rotate this longest segment to this longest segment, and that shows that that will be a 90-degree rotation. And the direction that I'll be going is clockwise. So I'm going to rotate around point A 90 degrees clockwise. I've completed the similarity that proves that triangle A prime B prime C prime is similar to triangle A double prime A B double prime C double prime. I started with a dilation. I dilated from center O with a scale factor of 2/3. Then I translate. I went right 5 and down 3 1/3. Finally, rotate around point A 90 degrees clockwise. Part C. Verify that in fact triangle ABC is similar to triangle A double prime B double prime C double prime by checking the corresponding angles and the corresponding side lengths. Then describe the sequence that would prove similarity for triangle ABC and triangle A double prime B double prime C double prime. Pause the video and complete part C. Here is what I found. I found the measure of angle A equal to the measure of angle A prime, and it was 18 degrees. I found the measure of angle B equal to the measure of angle B prime, which was 117 degrees. I found the measure of angle C equal to the measure of angle C prime, which was 45 degrees. Regarding the scale factor, remember it's the dilated length divided by the original length. So here are my corresponding sides for the 3 sides of the triangle, and here are their numbers, and they all have a scale factor of 2. So I have verified that in fact these triangles are similar. Then describe the sequence that would prove similarity for A, B, C similar to A double prime, B double prime, C double prime. Pause the video and do the description if you have not done it already. For part C, we will be proving similarity with triangle ABC and triangle A double prime, B double prime, C double prime. We've already calculated our scale factor, so go ahead and dilate it to the right size, draw the new figure, then do your sequence of rigid motions that will map it onto A double prime, B double prime, C double prime. Here's what my graph looks like so far. I've dilated the figure, and then I will need to translate it to the right 5, and then I will need to rotate it. The description should read, dilate from center O, r equals 2. Translate 5 units right. Rotate around point A double prime 90 degrees clockwise. Question D. Is it true that if triangle ABC is similar to A prime B prime C prime, and triangle A prime B prime C prime is similar to A double prime B double prime C double prime, then triangle ABC is similar to triangle A double prime B double prime C double prime? Yes, it is true. That was a lot of work to come to that conclusion. Nicely done. Our corresponding angles are equal in measure, so they all look the same shape. The sizes are different, but all have the same scale factor, so they are proportional. In summary, similarity is a symmetric relation. That means that if one figure is similar to another, we know that S is similar to S prime, then we can be sure that S prime is similar to S. Similarity is a transitive relation. That means that if we are given two similar figures, S is similar to T, and another statement about T similar to U, then we also know that S is similar to U. The sequence and the scale factor will be different to prove the similarity, but we know that it will be true.